I'm so happy to welcome Ryo Koyama, co-founder and CEO of noBGP, to the podcast. Welcome.
Thank you, Megan. Glad to be here.
So tell us about your history. Tell us a little bit about going all the way back in time in networking and even selling a TCP/IP stack to a chip manufacturer.
Yeah, I mean, I've been involved in startups for a long time. Ironically, my field of study was fluid dynamics, which really has nothing to do with anything, but I guess it does relate to kind of how packets flow. As you mentioned, the first startup company I did, we did the first silicon TCP/IP stack, which we were fortunate to have NVIDIA buy. I did another company which allows you to manage and monitor all kinds of equipment in the field. We had companies like Trimble and Caterpillar as customers on that side, and that also got acquired by a data server company. And now we have noBGP, which is looking to solve the data path problem for the internet today.
So for our audience that most likely the vast majority know nothing about networking, except maybe my colleagues at NTT, tell us, what is BGP and why did you name it noBGP?
So BGP is a border gateway protocol. So on the internet, most people are probably familiar with DNS, which is the names that you use to connect to different points. But how that data or the connections move from one place to the other is what BGP is for. So that decides the route that the traffic takes when one part of the internet wants to talk to the other part of the internet. The way that we think about it at noBGP is that the whole cybersecurity industry exists because of public DNS and public BGP. So as an example, a few summers ago, someone misconfigured a BGP server in Africa and all of Google's traffic routed through China for 8 hours. And so that's probably not what enterprises want today.
Right.
And so we always say, hey, so instead of relying on public BGP, deploy your own noBGP router, and then now all of a sudden all of your traffic is deterministic, because you're going to say, hey, I want this part of the internet or this part of my resource to connect to this one and use my router to do that. That way they can monitor and maintain all the traffic. And then if you have your own data center or if you're using your own dark fiber, you can make sure that that traffic follows that path. And we think that's the right way things are going to go.
So for the business audience and the more executive level in the tech sector that may not be following what you're talking about, let's step it back a bit to look at how you have, for many years now, understood that the public internet is the problem. And it's fundamentally insecure, and you often use this example of your postal address, and you get all this junk mail. And then now you also use the example of your phone number, and you get all this junk phone number. And we were talking about how the internet really basically has, with IP addresses like phone numbers or postal addresses, right? Help us understand a little bit more about why addresses matter on the public internet. Or your IoT device, right? Like your little cat feeder now has an IP address.
Yeah, and I think that's one of the biggest challenges. I mean, the internet is, it was invented 50 years ago, and they did a great job. It works anywhere. But that's the good and the bad. It's sort of the unexpected consequences. In my lifetime, we've gone from being excited when the phone rings to never answering the phone, because all that's available, you get mostly junk phone calls. And you talked about mail is the same way. Email is obviously the same way. And now that you have essentially the cloud, or you have the internet the way it is, and all businesses are moving towards there, it seems kind of obvious that you probably don't want to do it the same way that all the traffic goes. And so, if you want to make sure something is safe and protected, we talked about mail, that's sort of, you would use FedEx. You want to guarantee that delivery is going to happen. And we think the same thing is going to happen when you're at your on-premise data center going to the cloud resources. You want to make sure that that traffic moves exactly where you want it to go. Not hope it goes that way, not hope that somebody didn't misconfigure something, and so you ended up having problems.
Right. So let's get technical here as we talk about security and the network, because for most of our audience, folks don't really know how the network works and haven't really cared until recently. And there's something called IPv4 and IPv6. We made all these addresses for IPv4, and then we made all these addresses for IPv6, and then unfortunately now they have the same address, so it's like you have two phone numbers, and you're going to try to call using the same phone number, right? So help us understand what I'm talking about, why this matters.
Yeah, so IPv4 addresses, there was a limited number of those. And so once they started to run out, people were like, oh, we should come up with something else. And IPv6 is a lot more addresses. But the problem is people have heard of things like containers, and containers use also IPv4 addresses, but they tend to be what are called private IP addresses. So everybody has Wi-Fi at home, and they probably have like a 10.10. Something address. And that's fine, because you're at your house, and that's the only set of numbers that you need within your house. But what happens with private IPv4 addresses is, let's say you're deploying a bunch of containers or Kubernetes clusters at AWS, and then you also have some on-premise. They'll all use the same addresses. And so if these two networks have the exact same addresses, you'll have the same phone numbers used by two different resources, so they can't actually talk to each other. And the problem with that is it's solvable, but it's solvable by human hands. You have to really dig in there, fix it. And it doesn't mean it won't happen again. And this happens again and again where, somebody deploys something at AWS, and then they deploy another set of resources, and they deploy another set of resources, and all of a sudden they realize, they can't all talk because we just use the default settings. And so I think one of the challenges that hopefully companies like ours are going to be able to address is, hey, that's out in the wild. Can we provide a solution that solves that for a lot of people, where they don't have to manually go in there and configure it or rebuild everything? It just fits on top of it and solves those problems. And so I think the challenges with IPv4 and IPv6 addresses is, the truth is, no one wants to ever have to deal with those. And so I think a lot of people have done a great job in the networking industry of making it easier to manage. But the truth is, people don't want it to happen. And going back to our phone number conversation, because now you have your contact lists, if I see Megan is calling, I know it's you. If I saw some random phone number, that's probably not useful anymore. And the same thing is exactly the problem that's happening with network connectivity is, you know what you want to have connected, and you know that you only want those things connected. Why do you need an infrastructure that allows you to connect to anything, to anybody in the world? It doesn't make sense.
So help us understand how noBGP works for that. I've liked the analogy of Slack, where you just have somebody's handle and you can reach out to them and interact with them, versus, let's say, a series of numbers to identify them. It's a way to name the resource rather than having all of these, either the same number or just a number. Do I have that?
Yeah, that's right. I mean, so, again, I think the naming is really important. I think that's a thing that everybody understands. But then underneath that is how does the data travel? And so even if you're at AWS, and let's say you have some resources in the Northeast region and some in, the Pacific Northwest, if you wanted those two services to communicate with each other, most people will just use the public internet. But you don't know if that traffic's where it's gonna route. It might end up, because BGP might decide that, the best route is through the UK or somewhere else. And so you don't know where that traffic's gonna go. What noBGP allows you to do is says, hey, by the way, when these two resources talk, just use my router. And so then all the traffic goes exactly where you want it to go. If you are a CIO or a CISO, you'll be able to monitor all that, because you'll be able to see that all that connectivity happens there. But I think the broader thing that we're hearing just in public conversations is people really care about jurisdiction and governance. And the problem with the internet today is it's very global. And so if you want to expand out, and all of a sudden now you're in a foreign region with different jurisdictions, how do you deal with all of that? And what we're trying to do is trying to make it possible where you can decide exactly where you want the data, where exactly you want your services, and you can even spell out what jurisdiction you want without having to worry about manually setting up all the connectivity.
So I hear you saying two things. One of them is, when we go back to like our classic zero trust that starts with identity, this really empowers organizations to make those sort of policy and directory lists. What do you call them? The lists of
access control list, ACLs.
ACLs, thank you. Access control lists, and that really helps policy, and you can centralize it. Whereas if you were trying to do it the old way, it would be an unmanageable process. Do I have that from a
Yeah,
network management perspective?
and what gets hard is that it gets harder.
Right.
Today, what's beautiful about the cloud is it's very easy for a developer to say, I want to deploy 1,000 servers. The difficulty with all of that now is you've deployed 1,000 servers.
Right.
And then how do you want that to all manage and how do you want that to all connect? And I think those are the things that end up being difficult. So I'll use an analogy. Water is our most precious resource. It wouldn't shock me if, sometime in the next 25 years or something, you have a very dedicated spring and people will choose to have dedicated pipes to their house because they want that water as opposed to the public infrastructure. And I really think that that's the same sort of way that we should think about cloud networking, because you know where all your resources you are. You know which pipes you want laid for that.
Right.
And instead right now, we're just like, well, we'll use anything that's out there.
Right.
And it sort of is contrary to what makes obvious sense. And so I think it's sort of Occam's razor. The most obvious answer is the right one. And so our view is if you know you want point A to talk to point B, why don't you control the road that's going to let you do that?
So you have the resources and the people who are allowed to access the things. And for developers, let's talk about, that's what the CISO cares about, right? And how the traffic moves. So again, we're like talking CISO here. Let's think about the developers now and their desire to move large amounts of data from different places that are quite distributed, but also to be able to be in control in their code about the data movements and the access controls. And also help us understand the developer's persona in that, and also the DevOps folks.
Yeah, I think one of the things we're trying to do is make that relationship friendlier. So, one of the challenges is that the CISOs have to worry about governance and jurisdiction. And so often the developers are frustrated because they have to wait, because they have to wait for something to happen or some dedicated set of things to happen. And so what we've done is, so let's say you're a CISO and you have your own data center, but you also have, resources at a cloud or hyperscaler. And maybe because, you're a big company and you said, hey, we've set up private routes between, our data center and AWS. Well, normally, if you wanted to be able to talk over that, someone would have to get involved. And so, but if you deploy a noBGP router, you can say, hey, use this road that we've set up. But to the developers, it's very friendly to the way they want to speak because they can just script it. They can say, hey, use this router to run this traffic from point A to point B. And so we think that the advantage to that is that both people are happy. The developers get the experience that they want, which is they're not hamstrung waiting for a network ops team to configure the routes for them. And the CISOs are happy because it's following exactly the policy that they want to have followed.
I know you have a fun example about using these new little computers from Apple. Apple Minis, is that what they're called?
Mac Minis, yeah.
Mac Minis, yeah. And how developers could have fun with that. Did you want to tell that story?
The same sort of idea. What's happening with AI now is, people obviously want to do lots of stuff. And so, one of the popular things right now is people are clustering Mac Minis together. But that, again, it requires a lot of manual configuration. You have to do things that might be dangerous on your network. And so, again, if you use something like noBGP, all of a sudden you can just say, hey, here's a router, everybody connected this, and then now they can all talk to each other. And securely and very privately, which I think is, people talk about security and they often don't talk about privacy. And I think privacy is maybe the more important piece, because security is build the biggest lock you can. But it means that you have a key at some point, and so that's what you're fighting. You're fighting that path. But privacy could mean that you're in a room with no windows or doors, and there's only one road between those two endpoints, and only you're allowed to drive on that. And so I think privacy will become very, very important in a very different way. I think everything is going to be secure. Everything is going to be encrypted. Everybody will check those boxes. But the real question that people are not asking today is, where is the data traveling? And I think that will be the next big question that people will have to ask, because those resources exist. Data center companies like NTT have big, giant freeways out there that companies can use, but it can be very difficult. You need some special knowledge to use that. What we're trying to do is to provide a very modern tool of being able to use those resources without having to have lots of people there to configure that and set that up.
Yeah, network configuration requires a lot of people.
Yes.
And part of that goes back to these IP addresses and navigating all that, and your software just takes that whole headache away. Let's go back to the Mac Mini example and these kids getting together to kind of cluster these Mac Minis so that they can train an LLM or maybe a small language model. Help us understand the privacy piece from that example and dig in a bit on that.
Yeah, because again, there's this whole idea where you just make everything available and you can talk through it, but most people really don't want that. And so, if you think about the early days of network gaming, what everybody would do, they'd meet at the same place because it was easy to set up. But now the modern world is you expect to be able to be anywhere and make all that work. But so then the question becomes, how do you ensure that it's private? And again, going back to the road analogy, I think the only way that you can ensure it's private is you got to control the roads. And so that's the thing that we want to do is control the roads. You don't want to control the addresses because the addresses just mean you're telling people where to connect to. But you can use any roads. And so you really want to have the roads that make it.
So with that Mac Mini example, do I have that your Mac Mini, you only give access to the specific resource on your Mac Mini, not your entire Mac Mini, whereas before it would be your whole IP address?
Yeah, it could be the whole IP address or the whole compute resource and everything. And again, these are the terms people would say of things like what's called lateral movement. People will go from one side to another or scan the whole network. And these are the things that tend to get difficult because you don't really think about those things as being problematic. And the unfortunate reality is that hackers are very smart. So for example, in the United States, one of the biggest hacks that's happened is, a lot of these security camera systems have been hacked. Hundreds of thousands have been hacked. And so people immediately worry about, oh, what does that mean? Are people watching my video feeds? It's actually much more sophisticated than that. What people do is they go on the dark web and they sell denial of service attacks. But now they have millions of homes in the US as IP addresses that they can use for that because they've hacked these things. And they don't care about the people's video cameras, they don't care about their feeds, but these are computer and those are those sorts of resources. And people don't understand that those are the sorts of risks that they're happening. And so I think the only way to solve these things is you have to make sure everybody's living privately. And so if everything is private, it's as if you were in, like I said, this room and all your equipment's in this room. You have to figure out how to make that sort of reality without needing to physically be in the same space.
So you've created software that allows you to get really specific about what resource you're accessing where by the location or the device of the resource and also the name of the resource. Do I have that?
Yeah, most situations now, people effectively use DNS, which is naming for that. And people know what those resources are. And so we just make those resources, they can just say, hey, I need to connect point A to point B, but I want to use this resource to make those paths go that way. And I think what's interesting about that is we're trying to leapfrog the experience. And what I mean by that is that people say, okay, what have you done to make it easier? And what we're actually trying to do is to make it obvious and not make it easier, just make it the way things should work. Because what's interesting is that, I always joke that anybody under 35 doesn't know the world without the internet. And so they expect everything to connect. I have an app, why can't I just make these things sort of work? And so even if you're technically very sophisticated, you don't want this stuff to not work exactly the way you want it to work. And so now if you are a developer, you're like, hey, I got this data here, and I want to use this GPU here to do some training or something. I don't want to worry about that connectivity. I just want it to happen. And then if you have somebody who's worried about governance or something, that person wants that to also be easy without having to have somebody manually set that up every time.
Well, thank you for building the software for that. Before we wrap up, another one of our interviews is one of your key partners, Kachango. Did you want to touch on how you're working with them?
Yeah, so they're our first customer deployment. And so they are the leaders in what's called decentralized data centers. So they allow you to have data located in cross-jurisdiction, different environments. It's really the idea that move the data to where you want to be able to have it out there. In conjunction with that directly is how do you make those resources available to your environment today? So, especially with AI, especially with data today, everybody wants the data as close as possible to where you're going. But most people are cloud native. So let's say you have an AWS as your development environment, but now you have data stored all over the world. How we're working with Kachango is we allow you to make it look like all that data is within AWS or within Azure, because we make that plumbing invisible. So even though it might be in data centers scattered all over the world, close to where you're collecting the data, we make it so that your developer environment looks homogeneous from wherever you are.
So if I'm a customer of Kachango, help me understand how noBGP works. Let's say I'm a developer.
So one of the big advantages that Kachango provides is because they have such a decentralized data center infrastructure is that their customers can put the data wherever they want it. And usually it's the closest for lowest latency and just being able to develop, to dump all that data. But usually the developers who are maybe doing AI training or something with that data are working in a hyperscaler, like let's just say AWS. So typically you might have to think about moving that data or doing something so you can work on that workload. With noBGP, what you're able to do is you could be inside of AWS, and then you can access all that data as if it were within AWS, because we've already solved that networking piece for you. So it looks like it's in that same native environment without having to do that kind of configuration.
So is this in software? What does the demo look like?
Yeah, it's exactly in software. So what ends up happening is because you're deciding how the traffic moves, we deploy a router, but to the developer, they just say, hey, by the way, I need access to this data. And the router automatically brings it to their network environment. So it's entirely in software. So for example, if you're a developer, you're typically deploying containers or services today. And so now all you have to do is add one line of code that says, oh, by the way, I need to get access to this data that lives over here. Can you give me that? And then it just shows up in their environment.
And what would it be like without noBGP?
Usually you would have to call the network ops team and say, hey, I need to get access to this. Somebody would have to probably file a ticket, configure all the routes, make sure that works, or they'd have to arrange for somebody to move all that data. And that can be very problematic, or it might take a lot of time. Because what you really want is just you want instant access to that.
So what I hear you saying is we're talking about actual productivity gain of not having to have people configure something. You're also talking about cost because you're not moving data, which would cost money. So there's a lot of benefits to having this one line of code.
Yeah, I think that's the key is we've been fortunate to see the beauty of the internet, where everything just kind of works. And I think what we want to do is enable the private internet. Where everything works, but you get all the privacy, the governance, the jurisdiction that you want, but it's all done programmatically. So that to the developers, it's just, oh, this looks just like the internet, but everybody's happy because it's private and no one else can see it. And so that's what we're trying to do is enable that to work that way.
Awesome. Well, thanks for coming in, Rio.
Thank you so much,
I
Megan.
hope to have you back.
All right.